Okay, today we're going to start the voting and apportionment chapter. So, suppose a friend asks you, when did you last vote? What would your answer be? Maybe you tell your friend that last time you voted was during the last presidential election. Perhaps you would tell your friend that you prefer not to vote. Thinking about voting, presidential campaigns or advertisements for re-election may come to mind, but you can cast your vote in many ways. Have you liked a post, followed a creator, friended a stranger, or clicked a heart online today? In the digital age, it's possible to vote several times a day. Voting systems are not only the machines that drive every democracy on Earth, but they are also the engines driving social media and many other aspects of life. Deeper understanding of these voting systems will enhance your ability to successfully engage with the world in which we live. So, in this chapter, we'll become one of the founders of a new democratic country of Imaginaria. Have a great responsibility to the people of this fledgling democracy. You've been asked, you've been tasked with writing the portion of the Constitution that lays out voting procedures. In preparation for this important task, you will explore the various types of voting systems, from school board elections to Twitter wars. You will see how these types are alike, how they differ, and how they might be applied in Imaginaria. Most importantly, you will learn about the mathematically inherent advantages and disadvantages of the various voting systems so that you can make informed choices to better the lives of Imaginarians. So, the first thing we look at is a majority versus a plurality voting. When an election involves only two options, a simple majority is a reasonable way to determine a winner. A majority is a number equaling more than half or greater than 50% of the total. Let's take a look at the outcomes of the U.S. presidential elections to understand more. So we have a table displaying the results of the 2000 U.S. presidential election. Like most presidential elections, this election involved more than two options. If that is the case, it is possible that no single candidate will receive more than half of the votes cast. So here we have a total of 105,405,100 votes cast. To have a majority, you would need more than half of that. So if we take that and divide it by 2, 105,405,100 divided by 2, that comes to 52,702,550. So to have a majority, you would need more than that. So at least 52,702,551. You would need that many votes in order to have a majority. So nobody had a majority there. Now, looking at our first example, according to the Cook Political Report, a total of 158,394,605 votes were cast in 2020 U.S. presidential election. Of these, 81,281,502 were cast for Joe Biden, 74,222,593 for Donald Trump, and 2,890,510 for other candidates. Although U.S. presidential elections are not determined by popular vote, did either Joe Biden or Donald Trump secure a majority of the vote? So we take our 158,394,605 divided by 2, and that comes to 79,197,302.5. So, seeing as how Joe Biden had 81 million, yes, there was a candidate with a majority, and it was Joe Biden. Your plans for Imaginarian elections would likely include primary elections or preliminary elections. to select candidates for a principal or general election. Table 11.2 displays the results of the 2018 U.S. Senate Republican primary for Maryland. So consider the results of this 2018 Senate primary for Maryland. Which candidate won the primary for the Republicans? And did the candidate win a majority or a plurality of votes? Well, who got the most votes? This would be Tony Campbell won. And we can see by the fact that he only got 29.22%. He did not have a majority, so he won by plurality. So next type of voting method we look at is called runoff voting. Has your family ever debated what to have for dinner? Suppose your family decided on a restaurant and exactly half of you want to have pizza, but the other half want hamburgers. How do you decide when the result is a tie? You need a tiebreaker. Well, the new democracy of Imaginaria need tiebreakers. When no candidate satisfies the requirements to win the election, a runoff election or second election is held to determine the winner. How would runoff voting work in Imaginaria? There are many types of runoff voting systems, which are voting systems that utilize a runoff election when the first round does not result in a winner. The method for implementing a runoff election can vary widely, particularly in the criteria used to determine whether a candidate will be on the ballot in a second election. For example, a two-round system is a runoff voting system in which only the top candidates advance to the runoff election. In some two-round systems, only the top two candidates are on the second ballot. Or it may be any candidate who secures a certain percentage of the vote will advance. The Hare method is another runoff voting system in which only the candidates with the very least votes are eliminated. This can potentially result in several rounds of runoff. So the student government bylaws of a particular college require that a new president is elected annually by plurality voting. In the event of a tie, the bylaws require the candidates with the fewest votes to be removed from the ballot, and a runoff election to be held with the remaining candidates. This process is repeated until a single candidate receives a plurality and wins the election. So here we have the results of two voting rounds in the table below. Which two candidates tied in the second round? Well, let's see. I have 180, 180. So that is Fern and Lim. Does this mean there will be a third election? Yes. There was a winner who won. There wasn't a winner. If there should be a runoff, who must be removed from the ballot? Who received the least votes in the second round? And that is Kelly. So Kelly would be eliminated, and then we'd revote for a third time. So how do we do this? How do we determine a winner by plurality and majority election with runoff? To determine a winner by plurality or when a majority election with runoff occurs, we take these three steps. First, if a majority is required to win the election, determine the number of votes needed to achieve a majority. This is the least whole number greater than 50% of the total votes. If a majority is not required, move to step 2. Count the number of votes for each candidate in the current round of voting. If a single candidate has enough votes to win a plurality or a majority as appropriate, then you are done. Otherwise, eliminate a predetermined number of candidates based on the rules of the election. Elimination conditions may vary. For example, the rules may state that the candidates with the fewest votes will be eliminated, as in the Hare method, or that only the candidates meeting a certain threshold will move on, as in a two-round system. Once the appropriate candidates are eliminated, move on to step 3, hold a runoff election. If the runoff is simulated using a list of voters' preferences, renumber the preferences to reflect the remaining number of options in such a way that the original order of preference is retained. Then repeat step 2. So keep in mind that the second and third steps may be repeated as many times as necessary for voting procedures that allow multiple runoffs. So there are 6 members of the board of a parent-teacher association at a local elementary school. The president, the vice president, the recording secretary, the liaison to the administration, the treasurer, and the chief fundraiser. The board must decide which equipment to purchase for the classrooms with monies from the annual fundraisers. Preferences of the board members are shown in the table below. So this is a preference table. Each person rates their top choice 1, next choice 2, and so forth. So the board uses plurality method in a runoff in the event of a tie, such that the options with the least votes will be eliminated in each round. Which option will be chosen? Well, we have 6. The plurality. So option A has 2 first place votes. Option B has 2 first place votes. Option C has 1 first place vote. And option D has 1 first place vote. So option C and D will be eliminated. And then what we need to do is, okay, where here the vice president had option D as their first choice, so their first choice needs to be moved to their second choice now. Fortunately, that was option C, which has also been eliminated. So in this case, for the vice president, option B becomes their first choice out of the 2 remaining. And then the same thing here. Option C was eliminated. Option D was their next choice. That don't work. So here we have option B becomes and then option B would have 4 first place votes, whereas option A would have 2. So B wins. Now, in example 11.4, you are given a list that ordered each voter's preferences. This ordering is called a preference ranking. A ballot in which a voter is required to give an ordering of their preference is a ranked ballot. In any voting system in which a voter ranks or uses their ranked ballots is referred to as ranked voting. To vote for the Academy Awards uses a ranked ballot. The table below provides an example of a ranked ballot for the 2020 Academy Award nominees for Best Director. As you decide on voting methods that will be used in your new democracy, budget must be a consideration. You might consider a particular type of ranked voting called ranked choice voting, which simulates a series of runoff elections without the usual time and expense involved when voters must repeatedly return to the polls. The method of ranked choice voting, also called instant runoff voting, is a version of the Hare method, using preference ranking so that if no single candidate receives a majority, the least popular selections can be eliminated and the results can be recounted without the need for more elections. So note, ranked voting can be confused with ranked choice voting, but ranked voting is a more general category which includes ranked choice voting and several other voting methods. You have a kindergarten class votes on their favorite colors using a ranked ballot. Use the results in the following table to answer the question. The first question is how many students voted in total? Well, I have 4 plus 6 is 10 plus 4 is 14 plus 7 is 21. How many students voted for yellow as their favorite color? Yellow. Is there anybody with yellow as their number one? Nope. So that would be 0. How many students in the class indicated that blue was their favorite color while green was their least favorite? So blue 1, green 6. Blue 1, green 6. Blue 1, nope. So it's just those 4. These 4 right here. Now that we've covered how to read a summary of preference ranking, let's practice using the ranked choice method to determine the winner of an election. Recall that ranked choice voting is still the Hare method, where the candidate with the very least number of votes is eliminated each round until a majority is obtained. The difference here is that the voters have completed a ranked ballot, so they don't have to visit the polls multiple times. Here are the steps for ranked choice voting. Step 1, we need to determine the number of votes needed to achieve a majority, the least whole number greater than half the votes. Count the number of first place votes for each candidate. If a candidate has a majority, that candidate wins the election, and we are done. Otherwise, eliminate the candidates with the fewest votes. Reallocate the votes to the remaining candidates and repeat step 2. Be methodical to avoid arithmetic errors. Make sure that each time you count the number of first place votes, they sum to the number of ballots. So suppose that 58 Star Wars fans were asked to vote for their favorite Star Wars character. They were given a ranked ballot, and the results are shown in the following table. Use ranked choice voting to determine the winner. So first we need to determine how many votes would be a majority. Well, 58 divided by 2 is 29, so we need a total of 30 votes. So let's see. Here we have Han Solo with 10 and 2 for a total of 12. Here we have Princess Leia with 6 and 7 for 13. Here we have Luke with 8 and 2, or 3, sorry, for 11. Got Chewbacca with 5. Yoda has 7 and 6, which is 13. And R2-D2 has 4. So nobody has 30 votes, so we need to eliminate the lowest vote getter, which in this case is R2-D2. So we eliminate R2-D2. So when I eliminate R2-D2, his first place votes go to whoever was in second place. So let's get this out of the way, erase this so I don't get confused. So that means that Han gets these first place votes. So that means the only difference here is Han gets these additional 4. So now Han has 16 and R2-D2 has none. Still nobody has a majority. Next lowest rank is Chewbacca. So we eliminate Chewbacca. And his first place votes go whoever was in second place. So they go here. And that's 5. So that gives Yoda 18. And now Chewbacca is gone as well. Still nobody with 30 votes. So my next lowest person is Luke. So we eliminate Luke. Okay, these first votes go to Yoda. And these first votes go to Princess Leia. So Yoda received 8 more votes, which puts him at 26. And Princess Leia receives 3 more votes, which puts her at 16. So I think we have an error here somewhere. 6 and 7 is 13. She gets Luke's votes. 16. Anne has 10 and 2 is 12. Yes, R2. So I have 32 and yeah, that's 58. So we have a tie here. So technically, we would eliminate both of these and Yoda wins. Okay. So now let's look at board account voting. Ranked choice voting is one type of ranked voting that simulates multiple runoffs based on ranked ballots. Another type of ranked voting is the board account method, which uses ranked ballots that award candidates points corresponding to the number of candidates ranked lower on each ballot. To understand how this works, let's review the favorite colors of our kindergarten class from the table below. Let's focus on the votes represented by the first column of the preference summary. So right now we're going to just look at this column here. Each student had 6 options. The first column tells us that 4 students ranked blue as their first choice, red as their second choice, pink as their third, purple as their fourth, yellow as their fifth, and green as their sixth choice. Blue ranked higher than 6 minus 1 or 5 other colors. For each of the 4 students who completed their ballot in this way, blue would receive 5 points. Since there were 4 ballots with this order, blue would receive 5 times 4, which is 20 from the first column, to determine the points of each candidate. You have to find the sum of the points they receive in each column. To determine the winner of a contest using the board account method, we must compare total number of points earned by each candidate. Candidate with the most points is the winner. Each row of the preference summary corresponds to a single candidate. To find the number of points received by a particular candidate in the preference summary or their border score, we will need to focus on the row in which that candidate appears. So here's what we do. So first place, there are 5 below. We have 4 total, so this receives 4 times 5 or 20. This would receive 4 times 4 or 16, 4 times 3 or 12, 4 times 2 or 8, and 4 times 1, 1. Of course, last place receives 0. Then we just follow the same process. 6 times 5 is 30. 6 times 4 is 24. 6 times 3 is 18. 6 times 2 is 12. 6 times 1 is 1. And 0. Same thing here. 4 times 5 is 20. 4 times 4 is 16. 4 times 3 is 12. 4 times 2 is 8. 4 times 1 is 4. And 0. And then the last one here, 7 times 5 is 35. 7 times 4 is 28. 7 times 3 is 21. 7 times 2 is 14. 7 times 1 is 7, and 0. Okay, so we add these up. This is 39. This is 78. This is 38. This is 37. This is 69. And this is 54. So our winner is blue. So consider the color preferences of the kindergarten class once more. Using board account, blue wins. Oh, determine the total number of points, 78 points. Answering the following questions using the table below, which summarizes imaginary and voter preferences. So, use ranked choice voting method to determine the winner. So ranked choice voting, we need to add this all up. And I get 139. So I need 70 votes for a majority. Okay, so now I need to add up the number of first place votes. 12 and 19 is 31. 27 and 31 is 58. And 29 and 21 is 50. Okay, I don't have anybody with a majority. And the person with the lowest is candidate A. So we eliminate candidate A. And then these 12 first place votes go to the second place person, candidate B. And these 19 first place votes go to the second place person there. So adding 12 to 58, I get 70. And here I get 69. So B wins by ranked choice voting. Okay, next we want to use the board account method to determine the winner. So there's 2 people below first place, so this is 2 times 12 or 24. And that's 12. That's 38. That's 0. That's 19. That's 54. That's 27. That's 0. This is 58. That's 0. And this is 29. This is 62. 31 and 0. And this is 21. Nope. Sorry. 42. 2 times 21. 21 and 0. Adding them up, I get 118. I get 149. And I get 150. So by the board account rule, the winner is C. So comparing the results of the two methods, did the same candidate win? No. What observations can you make about the results? Well, with our vote count so close, with vote counts so close, a slight shift can change the results. Because if you recall, With the ranked choice, it was 69 to 70, and with board account, it was 149 to 150. Board account method may seem too complicated to even consider using for Imaginaria, but each voting method has its own pros and cons. Board account method, for example, favors compromise candidates over divisive candidates. Compromise candidate is not the first choice of most of the voters, but is more acceptable to the population as a whole than the other candidates. A divisive candidate is simultaneously the first choice of a large portion of the voters and the last choice of another large portion of voters. So this brings us to our next voting methods called pairwise comparison and Condorcet voting. We've discussed two kinds of ranked choice voting methods so far, ranked choice and board account. Third type of ranked voting is the pairwise comparison method, in which the candidates receive a point for each candidate they would beat in a one-on-one election, and half a point for each candidate they would tie. One candidate earns more points than the others, then the candidate wins. This method is one of several Condorcet voting methods, which are methods in which candidates are ranked and then compared pairwise to each other, a candidate having to beat all others in order to win. These methods vary in the way candidates are scored, and there is not always a clear winner. A candidate who wins each possible pairing is known as a Condorcet candidate. These terms are named after Marquis de Condorcet, a French philosopher and mathematician who preferred the pairwise comparison method to the Hare method and made public arguments in its favor. If you include a Condorcet voting method in the Constitution of Imaginaria, the election supervisors may want to use a pairwise comparison matrix like the one in Figure 11.3. It's a tool used to list the number of wins associated with each pairing of two candidates. Each candidate will receive a point for each win and half a point for each tie. Each pairing is listed twice, once for the number of wins of a candidate over a particular challenger, and once for the number of wins of the challenger over the candidate. So I use something slightly different than this. So steps to determine a winner by pairwise comparison method using the matrix. On the matrix, indicate a losing matchup by crossing out a box and tie matchups by drawing a slash through the box. Award each candidate 1 point for a win, half a point for a tie, and 0 points for a loss. Identify the winner, which is the candidate with the most points. According to Variety magazine, there were 8,469 eligible Oscar voters in 2020. To make our matrix easier to work with, we rounded that number to 8,700. We never do this in a real voting situation. Suppose that the voter preferences for the ballot for best directed have been as shown in the table below. We want to refer to the table to answer each question. So let's construct a pairwise comparison matrix for best director ballots. So again, I did this a little differently. So first we have our directors, and I shortened them to their initials where space concerns. Then we'll put them here as well. So this is similar to what the book does, but it gets the way the book does it can get a little confusing. So essentially what I'm going to do is treat this as a battle. Well, MS won't fight MS. TP won't go to against T, and so forth. So these are all gone. There's no comparison. Now we have MS in comparison with TP. I'll do a couple of these and then I'll just put the winners. I'm looking at Martin Scorsese and Todd Phillips. So here Todd is better, here Martin is better, here Martin is better, here Todd is better, here Martin is better. So who is preferred over the other by more people? And in this case, it's Martin Scorsese. So the way I would write this is just MS wins this. And of course, if there's a tie, I would just put tie. So our next comparison will go MS against SM. So again, I'm looking at Martin Scorsese and Todd Phillips. So here and here. Scorsese's there and there. Mendez there and there. Scorsese there. So again, Scorsese gets the win. So Martin Scorsese, Martin Scorsese. Okay, then we have Scorsese versus Quentin Tarantino. And now we're these two. Again, 3 beats 4, 1 beats 2, 1 beats 4, 3 beats 5, 2 beats 3. So again, Scorsese wins. Looking real good for Scorsese right now. And there we go. Then we try our last battle for Scorsese. All right, battles Bong Joon-ho. 2 is better than 3, but 1 is better than 3. 2 is better than 4, and 1 and 1. So Bong wins that one. So we're looking to see, well, we're constructing the table right now. So we follow this process through all of them. I've done it ahead of time. So TP beats SM and TP beats QT, but TP does not beat JB or BJ. So again, it's TP, TP. And then for Sam Mendes, he loses to Quentin Tarantino and to Bon Joon. And Quentin Tarantino loses to Bong Joon as well. So there's our chart. So who's the best director? Well, looks like Bong Joon. Because here, he beats everybody. And he is, yes, he is a Condorcet winner. Okay, so we have 3 key questions to keep in mind. Before you decide if you want to use the pairwise comparison method for imaginary elections, let's consider 3 questions that might affect your decision. Is there always a winner? If there is a winner, is the winner always a Condorcet candidate? And if there is a Condorcet candidate, does that candidate always win? So let's think about why these questions might be important to you if you choose the pairwise comparison method. First, if no candidate meets the criteria to win an election, you will need a backup plan such as a runoff election. Second, if the winner is not a Condorcet candidate, then there is at least one candidate who beat the winner in pairwise matchup, and the supporters of that candidate might question the validity of the election. Finally, if there is a Condorcet candidate who beat every other candidate in a pairwise matchup, it is reasonable to conclude that it would be unfair for anyone else to win. The rest of the examples in this section should illustrate these key concepts. Pairwise comparison matrix is given. Determine the winner by the pairwise comparison method. If there is not a winner, explain why. There is a winner, tell whether the winner is a Condorcet candidate. So P wins. Well, it says P wins, but not a Condorcet because P lost to Q right here. Again, I think my comparison matrix works better. And now you have the answer to the second key question. The pairwise comparison matrix in example 1110 is an example of a scenario where a winner is not a Condorcet candidate. The answer to the third question is not as clear. If there is a Condorcet candidate, does that candidate win? So far, we have not come across a contradictory example where the Condorcet candidate didn't win, but we cannot know with certainty that it is not possible. By looking at examples, instead, we will need to use some reasoning. Let's review some particular cases of elections with a certain number of candidates, and then we'll try to generalize the scenario to an election with n candidates. So, suppose there is an election with 26 candidates, A through Z, and that candidate C is a Condorcet candidate. How many points did candidate C win? Well, to be a Condorcet candidate, they would have had to beat everybody else. So, 25. What is the greatest number of points that any one of the other candidates could win? Well, they could beat everybody but C. So, 24. Is it possible for candidate C to lose or tie? And that is a no, because a Condorcet candidate must beat every other candidate. So let's consider general case where there are candidates. One of the candidates is a Condorcet candidate. So that should be where there are n candidates. Since the Condorcet candidate wins all matchup, the Condorcet candidate wins n minus 1 points. Since each of the other candidates lost to the Condorcet candidate, the most a single candidate would win would be n minus 2. Since the Condorcet candidate won n minus 1 points, and each other candidate won points n minus 2 points or fewer, the Condorcet candidate is the winner. You have your answer to the third key question. There is a Condorcet candidate. Candidate is always the winner. So the last type of voting system you will consider for your voting democracy is an approval voting system. In this system, each voter may approve any number of candidates without rank or preference for one over the other among the approved candidates. And the candidate approved by the most voters wins. This voting system has aspects in common with plurality voting and Condorcet voting methods, but it has characteristics that distinguish it from both. An approval voting ballot lists the candidates and provides the option to approve or disapprove. Approval voting has the appeal of being simpler than ranked voting methods, also allows an individual voter to support more than one candidate equally. This has appeal for those who do not want a split vote among few mainstream candidates to lead to the election of a fringe candidate. It also has appeal for those who want an underdog to have a chance of success because voters will not worry about wasting their vote on a candidate who is not believed likely to win. So the Chanellis family is trying to decide on a restaurant, but now they don't want to deal with multiple runoffs or even ranking. They will use the approval voting method shown in the following table. Each family member will approve their top two choices. Rainbow China won when multiple runoffs were used. Find the winner for tonight's dinner. So how many yeses does each restaurant have? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. So what would be the outcome of this election? It would be Doughboy's Pizza. So what would be the outcome of the election if every member of the Chinolli's family approved their top three choices? So if it has a 1 or a 3 in it, it's approved. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2. So here we would have a tie between Rainbow China and Doughboy's Pizza. So we've covered a lot of options for voting methods. Now you need to decide which one is best for our Imaginarian. Imaginarians might consider characteristics of certain voting systems desirable and others undesirable. In some cases, voters may consider these undesirable traits to be flaws in voting systems that are significant enough to motivate them to reject that system. If you're feeling a bit overwhelmed by this decision, maybe it would help to read about experience of others who have faced similar questions. So let's go back to consider the 2000 U.S. presidential election, in which Green Party candidate Ralph Nader and Reform Party candidate Pat Buchanan were on the ballot running against the mainstream candidates, Democrat Al Gore and Republican George W. Bush. The voting results for Florida are given in the table below. So in more than one state, Buchanan was able to split the Republican vote enough to allow Gore to win that state. Nader split the Democrat vote in Florida and New Hampshire by enough votes to prevent Gore from winning those states. Had Gore won either state, he would have had enough electoral votes to win the election. Instead, Bush won. This is an example of a flaw in the plurality system of voting. The spoiler. A spoiler is a less popular candidate who takes votes from a popular candidate with similar positions, swinging the race to another candidate with vastly different views that they would not support. This encourages voters not to vote for the candidate that they perceive to be the best, but instead for the candidate they can live with, who they perceive to have a better chance of winning. Some voters may prefer a method such as approval voting, which does not have this trait in common with plurality voting. So here's what we're going to do. We're going to Extrapolate the results of an approval voting method using table 11.3 and the following assumptions to extrapolate the results. So 100% of Pat Buchanan's supporters would go to Bush. So Bush starts out with 2,912,790. And he's going to get all of Pat Buchanan's supporters. So Pat Buchanan, 17,484. Now Al Gore received 2,912,790 votes for himself, and he's going to receive 100% of Ralph Nader's votes, which was 97,488. Now, next we're going to say 72% of libertarians would vote for George W. Bush. So my libertarian vote was Harry Brown. So I need 72%, 0.72 times 16,415. And that gives me 11,819. And then the other 28% will go for Gore. It gives me 4,596. So taking care of this, and this, then 50% of supporters of other candidates would approve of Bush, and 50% would approve for Al Gore. So the other candidates were 6,680, so that would be 3,340 for both sides. And half of the supporters of George Bush would approve Pat Buchanan, and half would approve Harry Brown. And the supporters of Al Gore would all approve Ralph Nader. I'm not sure what that is. Okay, so let's do this. Let's add this up. So I have plus 17,484 plus 11,819 plus 3,340. So 2,945,433. And here I would have 2,912,790 plus 97488 plus 4596 plus 3340. 3,018,214. Now here's the weird part. So all the Bush voters would approve of half of the supporters of George Bush would approve of Buchanan, and half would approve of Harry Brown. So half of Bush, which was 2,912,790 divided by 2. Add that to Buchanan, 17,484. And Buchanan would have 1,473,879. And 1456395 plus Brown, 16,415. Brown would end up with 1,472,810. Now here's where it goes kind of screwy. All of Al Gore's supporters would approve of Ralph Nader. So 2912253 plus 97488 3009741. So if we did this by approval voting, Using this information, not only would Gore have beaten George Bush, but Nader would have as well. So that's why this can get really weird depending on what we're doing. So here we have the juniors at a high school in Central Florida are voting for a theme park to visit for an end-of-year field trip. The options are Disney's four theme parks: Animal Kingdom, Magic Kingdom, Epcot, or Hollywood Studios. Determine the outcome of the vote by each of the given voting methods. Plurality, so who has the most first place votes? Well, right there, 35%. Animal Kingdom. Ranked choice. So Hollywood Studios would fall off. Then Magic Kingdom would fall off. And then Animal Kingdom would get Magic Kingdom. So again, it would be Animal Kingdom. Now the border count's a little more difficult. So I'm just going to count this as 35 instead of percentages. We're going to count that as 35, 25 votes, and 30 votes, just to make it easier. So this would be 3 times 35, or 105. This would be 2 times 35, or 70, and 1 times 35. Here we would have 3 times 25, which is 75, 2 times 25, which is 50, and 1 times 25, which is 25. And here we would have, well, these would be zeros, of course. 3 times 30, which is 90. 2 times 30, which is 60, and 1 times 30, which is 30. Adding these together, that's not 180, 130. This is 175, 125, and 110. So in this case, word account, Magic Kingdom would win. And that finishes up our first section in this chapter.